Somewhere in the jungle, there's a pond. And in this pond, there's a log. And on this log, there are 7 turtles. Here represented by dinosaur figurines because that's what they had at the Dollar Tree.
There's a path next to the pond, and sometimes somebody walks by. When they walk close, the closest turtle jumps into the pond.
Each one of these turtles weighs a different amount, either 1, 2, 3, 4, 5, 6, or 7 pounds. These turtles are all in a random order on their log. When someone walks by and the first turtle jumps in, it sets off a chain reaction. The second turtle will be frightened and jump too, but only if the first turtle weighs more than it. The third turtle will jump in if the weight of the first 2 turtles is greater than or equal to its own weight. If, at any point, the turtle weighs more than the combined weight of the previous turtles, the chain reaction ends. The question is then, on average, when someone walks by, how many turtles jump into the pond? There are many different combinations to the way the turtles could be arranged on the log. 7 factorial, which is equal to 5,040 combinations. A much simpler version of the problem can be seen by looking at the same concept, only with 4 turtles. 4 factorial is 24, and all the combinations of 24 can be shown quickly. With 4 turtles, there are 12 cases where 1 turtle jumps, 11 cases where 4 turtles jump, and a solitary case where 2 turtles jump. Thus, the average for 4 turtles depends on definition. For mean, it is 2.47, for median, it is 1.5, and for mode, it is 1. The term average is somewhat deceptive, because while the mean is 2.47, in the great majority of cases, either 1 turtle jumps or all the turtles jump. With 7 turtles, the same concept applies. There is a symmetry depending on which is the first turtle to jump. With a 7-pound turtle, there is a 100% chance that all the turtles jump, while with a 1-pound turtle, there is a 100% chance that the reaction ends. With a 6-pound turtle, there is a 5/6 chance that the reaction continues, while with a 2-pound turtle, there is a 1/6 chance that it will continue. These odds complement each other, and the average number of turtles that jump is around 4. But in the great majority of cases, either 1 jumps or all jump. Out of all the 5,040 possible combinations, there are only 18 where 3 jump. This is because any combination of 4 turtles will add up to 10, which is more than the weight of our heaviest turtle. With 7, 10, 15, or however many turtles we have in this configuration, the result will always be evenly divided between 1 turtle and all the turtles, with only a few cases where the reaction goes a few steps and then stops. While the turtle problem is an artificial mathematical puzzle, it in some ways seems to be a good model for why change happens, or doesn't. Sometimes fashions, activities, and product choices catch on, and sometimes they do not. And what is the reason that Great Britain prefers tea but Scandinavia prefers coffee? Why do you use QWERTY keyboards and not Dvorak? Why did Tab soda never catch on? Because of the size of that first turtle.